You. Good. So we are going to move next to the community projects. So I am going to show you or present this to you in two blocks. We have four community projects. So let's go to the first block with the two community projects, and then I will introduce the other two straight after. So first of all, I am going to present to you the project from Jesus Hidalgo from Venezuela. So, and it is not that we were talking about IoT and about environments. This project is about rain gauges and how control systems or how can more control and improvements on control systems for rain gauges can be improved, especially for sprinkling systems. So let's check this out. And sorry, the next one that we are going to present as well is from Vatsalya Baduria from India, who is also, I mean, I love that we have young people also presenting community projects. This is awesome. So this project is about smart farming, and we are going to get to know how the hardware that was designed and this Android application can show real-time moisture and temperature data gathered to control, all of the smart farming projects. So this project is using ISP and sensor technology. So let's watch this, and then I'll come back and show you the rest of the projects. Thank you.
Hello everyone, I am Vatsalya and I am 16 years old. I am a student studying in grade 10 and I live in India. And it has been more than 2 years since I have been making projects with Arduino. So now let's discuss about the project. So my project name is Krishi Navinikaran, which means development in agriculture. The technology which we use in this project is Arduino and MIT App Inventor to create hardware and application respectively. The aim of this project is the upliftment of farmers who are not aware of the cropping seasons and the adequate situations of the climate. My basic idea at first was to make aware farmers with government policies and schemes given to them so that they are not fooled by anyone according to their consumption and production. I started this project 6 months back for my school competition and added Arduino in it in less than a month ago. So now it's time to showcase my app to all of you. The app looks something like this, and if you look closer, there's an option for first temperature and humidity sensor, and when we click it, a different screen opens, and this is somewhat the layout, and then we have to connect it. You can see my Bluetooth module is visible at C05, and I'll then click it. As you can see, it is giving temperature 24 degrees Celsius and humidity 95 degrees Celsius. Now let's show you the hardware. The hardware looks something like this, and it contains one DHT11 sensor, one HC05 Bluetooth module, and an Arduino Uno, and some resistance and wires. So that was it. I told you why I started this project, the technology which I used, and the basic aim of this project. You can get in touch with me on my email ID, that is vatbhadauria@gmail.com. I'll write my email ID on this. Thank you so much.
Hello. So taking advantage of having you both here, thanks for participating. I'm really happy to have you from Venezuela and India. And this is really great. So we already have some questions. So the first one for Jesus. Which basic skills would you require for a user to install his/her own rain beacon? How long did it take to prototype the whole project?
Okay, thank you very much. I'm very happy to be here with you, with all the audience. Our idea is to have a very easy device that you just place it in a outside and just turn it on. Then you need to be near a LoRaWAN gateway, and that's it. All the information, small packages of information fly to the LoRaWAN gateway, and the whole system calculates the rain, the based on the LoRa strength signal.
Okay, yeah, I think I forgot to mention that it was using LoRaWAN technology, your project. So this is
Yes.
pretty good to know. Good. So we have another question for Batsiala. Can you can already turn on? Sorry, I'm reading the wrong question. Good. Let me go. Which are the possible applications of this project? Who is the perfect end user, and how many parameters can you measure at the same time? So this is a group of three questions. So let's see. Thank you.
So the possible applications of this project is either to measure temperature or humidity. Other than the IoT feature, we have added all the information that a farmer needs from sowing to the harvesting of a crop, including all the government schemes, policies, and also a farmer's helpline number, which the farmer can directly contact with the government. Also, Also, the perfect user end of this project that I made is the upcoming farmers or the farmers who don't have any knowledge about their adequate moisture of the seasoning of the crop or the climate regarding that.
Yeah, yeah. My project it's very useful for farmers too. The production of wine it's very important to measure the the, the rain, because too much rain in the grape fields it will be not very good. It doesn't have to have too much water, and but you can use it for example, oil industry applications, because you need to measure rain when it's raining because several reasons. And here the question says, how many parameters can you measure? Well, you can measure as any parameter if you want. For example, pressure, temperature, humidity. You also can calculate dew point, and a lot of if you have several sensors connect to the LoRaWAN gateway node, you can send all information to the through the Helium network.
Okay, great. I think there's another question for you, Jesus. It says, has the LoRa connection been reliable in a city location? What kind of range are you getting?
Yes, very reliable. We have experienced about 4 kilometers inside a city, going through buildings, going through concrete structures, and because you have a very big network, hotspot networks in China, Europe, United States. You will find a very easy a node gateway very near from you inside a city. Now at the uh, outside, long far away from the city, you need to install a gateway by yourself, but it will be a very wide range for each gateway,
Okay,
about
great.
kilometers.
Good. We have another question for Vatsalya. So, has your project been tested in a live location yet, on a farm, for instance? This is a really good question.
Yes, we have also tested a project in a farm, which is basically near to my home. That is, within the radius of 5 kilometers. We tested this project for almost 5 days continuously to to see whether this is accurately giving the information or not.
Great. I think we have a little bit of time for maybe one or two questions max, so we can give time for the next block. So this is a question for Jesus. What kind of accuracy are you getting from the rain detector?
Well, this project was inspired on an investigation I made about in 2014, and we with satellites, geostationary satellites, and we find about a 90% of accuracy. Now we are working with um, Arduino devices and LoRa network, and we are getting more or less the same accuracy,
Great.
90%.
Oh, great. Do we have any other question? I think we don't have more questions. It appears so. We are checking here our. Okay, let me see. Yeah, another question for Batsalia. Are you planning to add anything else to your project? Another great question. Yeah.
Yes, I am planning to add several components in this project. One of them is a live geolocation of the temperature and humidity of a location. For example, I am sitting in a different state and a guy is sitting in a different state. So to connect, we are actually planning to geolocation satellites, which would actually help to make a real difference for this project.
Great. I don't know if we have time for another question, but I think we should move maybe to the next block so we can present the next projects. And I want to thank you both, Jesus and Batsalia, for
Thank you, sir.
sharing your work with us. Thanks a lot, and we wish you the very best.
Thank you very much. Have a great day for all.
Good. So